And here we're going to talk about the refrigerator or the air conditioner, because it works exactly the same, and how it works. So here I have kind of a drawing of a refrigerator. The big box is supposed to be a refrigerator. Down here we have a compressor. It compresses the refrigerant into a region here where it's exposed to the outside, so air usually is blown on that, and this is cooled. This is where this is being cooled, and then it gets pushed into the refrigerator past what we call an expansion valve. Once the refrigerant, which is in a liquid state over here, gets pushed into this region right here, it turns back into a vapor. And of course, when something goes from a liquid to a vapor, it absorbs energy. Where does energy come from? It takes heat from the refrigerator compartment, and even though it's already cold there, it grabs additional heat and makes it even colder. So that gas then, that absorbs the heat from the refrigerator, is then with a compressor pushed back out here, goes past this valve, and then it becomes pressurized. And of course, when a gas becomes pressurized, look at a PT diagram. When a gas becomes pressurized, you increase the pressure, it turns it back into a liquid. So that's what happens right here. The gas gets turned back into a liquid via the compressor, and that is where the work is done. So you have to have energy here. You have to actually have a wire that's connected to the local outlet. The electricity provides the energy for the compressor, which does work to compress the liquid. It can then cool, allow the heat to escape into the atmosphere, into the kitchen, gets pushed past the expansion valve, pressure drops, the liquid, the refrigerant, expands again, and then it absorbs heat, and it just continues on and on and on and on like that. So the schematic diagram for that is we extract heat from the cold reservoir by doing work, and then we expel heat into the hot reservoir. And of course, the work that we use to do that then also turns into heat. The way in which we calculate the efficiency of that is not really by like we do for an engine. We actually calculate what we call the coefficient of performance. We use the letter K for that, and we call that the coefficient of performance of the refrigerator or the air conditioner. And K is then defined by the amount of heat we pull out of the cold reservoir, which is Q sub C, divided by the amount of work it takes to do that. And of course, the greater K, the better, because that means you take more heat out of the cold refrigerator, and you do that by using less work. So you want work to be as small as possible, and the heat we take out of the refrigerator as great as possible. And so therefore, the greater the K, the better the refrigerator. The greater what we call the coefficient of performance. Then of course, another aspect of the refrigerator is that you want to have some insulation around the refrigerator to prevent heat from seeping back into the refrigerator. So the better the insulation, the longer it takes before heat goes back in the refrigerator and makes it warm again. So we can't forget about the insulation of the refrigerator as well. So now you get a basic idea, basic understanding of how refrigerators work, how to calculate the coefficient of performance, and I'll show you a little example of that in my next video.